And so we're back. We're here today to talk about more data distribution, and today's topic is all about data distribution, all those words you know and have come to love: mean, median, mode, and range. So the joke of the day: why would you use the median to describe an average politician? Answer: because he or she is middle of the road. So let's talk about our objectives today: describing the central tendency of a data set and creating and interpreting box and whisker plots. You should pause the show right now if you need to get this vocabulary down, but these are the words that we'll be discussing in our lesson today: mean, median, mode, range, outlier, first and third quartile, interquartile range, abbreviated IQR, and a box and whisker plot. These are all measures of central tendency, and they describe a center of a set of data. Measures of central tendency include the mean, median, and mode. So our definition for mean is the average of the data values, and we all know we've done many mean problems before, but in this case we're going to take the set, the number, add them all together, and divide by the number of values in the set. The median is the middle value. It's like the median on the freeway when the values are in numerical order, the one in the middle. If there's an even number, then you take the mean of the middle two. The mode, we remember this because it rhymes with most. It's the one that occurs more commonly. We can have more than one mode. We can have a bimodal set of data, which would indicate that we had two modes. The range is the distance between the greatest and the smallest set number in our spread. So let's look at example 1, finding mean, median, mode, and range. The weights in pounds of 6 members of a basketball team are given. Find the mean, median, mode, and range. Write the data in numerical order. Add all the values and divide by the number of values. Here you see that displayed. And we can see that our mean is 156. There's an even number of values. Find the mean of the two middle values. In this set, we have two values in the middle. They happen to be the same, and their average would be that value. So additional, to be continued, example 1, 150 and 156 are both occurring more than any of the rest of the values. We call this bimodal. We have two modes, 150 and 156, and by finding the range, we're going to take the greatest value, subtract the smallest value, and find the difference between the two. I want you to check it out. Example 1, we've got the weights of 5 cats. Let's find the mean, median, mode, and range of the data. Come right back here, and we'll check your answer. So they've listed the data in numerical order. We're adding all the values, dividing by the number of values, which is 5. You can see that arithmetic done here. A total value of 70 divided by 5 gives us an average weight of 14 pounds. Since there's an odd number of values, the value in the middle, 14, is our median. It says now we're going to find the data range, or excuse me, the mode. Because 12 and 14 both occur twice, we have a bimodal set of data. We have two modes, and so we list them both, 12 and 14. And the range from smallest to largest is 4. We're going to talk about the box and whiskers plot. A value that's very different from any other value in the data set is termed an outlier. We're going to look at how that appears in a set of data if we were to display it. Here you can see the mean of the data outside of the cluster of data, and that happens because we have something called an outlier, a value that's much different than the rest. You can see how that changes the average value. In example 2, it says identify the outlier in this data set. Determine how the outlier affects the mean, median, mode, and range. We're going to list this data in numerical order. We're going to look for a value that is much less or greater than the rest, and we can see everything is in the teens and 20s, aside from our one value, 75, which is far beyond on the great side. The outlier we're going to find the average with it and the average without it and talk about the differences. So you can see as we add the 6 values, dividing total by 6, we get 29. In the middle we see 21 for our median, and 21 is occurring twice, so it becomes our mode. The range is affected greatly by an outlier. We see a range of 59 for the data with the outlier. If we look at without, omitting the outlier, we see a mean of 19.8, a median still 21. 21 is still our mode, but the range drops to 7. So we can compare and contrast with and without the outlier. It increases the mean by 9.2, the range by 52, but it had no effect on the median and the mode. Here's yours to do. Check it out. Example 2. Want to do the same thing. Identify mean, median, and mode. Identify the outlier and compare with and without that outlier. So putting our data into numerical order, we see 3 as our smallest value. 21, 24, 24, 27, and 30. Determine how the outlier affects the mean, median, mode, and range. So here we go. Looking for a value much greater or less than the rest, we can see that 3 is far less than the rest of the data. The outlier is therefore 3. With the outlier, we look at all of the measures of central tendency. With it, we get a mean of 21.5, a median of 24, a mode of 24, which is occurring twice, and a range of 27. Now we're going to look at the data without the outlier. Mean 25.2. The median remains the same. The mode remains the same, and our range falls to 9. So in comparing the two sets of data, the outlier being 3, it decreases the mean, being much smaller than the rest of the data, is decreasing our average by 3.7, increasing the range by 18, and it has no effect, once again, on the median and the mode. As we see in example 2, an outlier can strongly affect the mean of the data, having little or no impact on the median and mode. Therefore, the mean may not be the best measure to describe a data set that contains an outlier. In such cases, the median or mode may better describe the central tendency. So let's look at example 3. Rico's scoring on 6 history tests. We can see he has an outlier. He's not very much proud of that one. And a mode and his scores. Answer each of these questions. Which measure best describes Rico's scores? Well, we could think of a mode, which he would have achieved most often, or an average on all. The mean is 70.7, his median is 73.5, and he has no mode. Median 73.5, the outlier of 54 lowers the mean, and there is no mode. Part B says, which measure should Rico use to describe his test scores to his parents? Well, that would be the one with the greatest value, I would assume. Median 73.5, it's greater than the mean, and there is no mode. So you guys try example 3, check it out, and then get right back here and we'll correct your answers. So here's Josh's 5 scores. Use the mean, median, and mode to describe his scores and to answer each of the questions. Which of these measures best describes Josh's scores that he received most often? The mean being 80, median is 81, and the mode is 75. He has 2 scores of 75, which is the mode. Which measure best describes Josh's scores? A median of 81, it's greater than either the mean or the mode. We're going to talk now about a box and whiskers. Measures of central tendency describe how data cluster around one value. Another way to describe a data set is by its spread, how the data values are spread out from the center. We're going to talk in terms of quartiles. Quartiles divide data into 4 equal parts. Each quartile contains 1/4 of the values in the set. The first quartile is the median of the lower half. Second quartile is the median of the data, and the third is the median of the upper half. So to get started, we're going to find the middle and cut the two halves in half again. First quartile is sometimes called the lower quartile, and the third is sometimes called the upper. The interquartile range, or the IQR of a data set, is the difference between the third and first quartiles, and it represents the range of the middle half of the data. So if we're looking at this data here from 1 through 9, we can see it has a range of 8, the entire range from one end to the other, but the interquartile range is found by going from the first quartile data, which is 3 in this case, to the third quartile data, which is 7. So we have an interquartile data range of 4, and we can see our median in the middle is 5. This data is going to help us and allow us to make a box and whiskers plot, which can be used to show how the values are distributed. You need 5 values to make the box and whisker: the minimum, or the least value, the first quartile, the median, the third quartile, and the max, or the greatest value. So we're going to take this set of data in example 4 and create our box and whiskers, remembering all the pieces and parts of central tendency we need. We're going to order it from least to greatest. And here you can see our lowest value and our highest value. We're going to take the minimum, the first quartile, the second quartile, or the median, the third quartile, and the maximum. We're going to draw our number line given those values. So the first quartile, or the left side of the box, is found at the first quartile. The right side of the box is found at the third. And the median is the line drawn in the middle, not necessarily in the physical middle, but inside the box. The min and the max produce the ends of the whiskers. Half of the scores are between 6 and 12. 1/4 of the scores are between 3 and 6. The greatest score earned by this team is 20. So you guys create your box and whiskers with this set of data. It's example 4. And let's see what you get when you come back. So first thing we're going to do is list everything in numerical order. Here they are. We're going to identify the 5 needed values. That's the lowest, the highest, the middle, first quartile, second, and third quartile to give us our interquartile range. Remembering the first quartile is the left side of the box, third quartile is the right, the median is the line within the box, our max and our min are the range or the extent of the whiskers. Half of the data are between 13 and 18. 1/4 are between 11 and 13. And the greatest value is 23. So the box and whisker plots show the number of mugs sold per student in 2 different grades. So we're going to read and interpret this box and whisker plot. So we're looking at the 8th graders versus the 7th graders. About how much greater was the median number of mugs sold by the 8th graders. Here's our median. Then the median number of mugs sold by the 7th graders. And we can see that's a difference of about 32 to 38. So they came up with a difference of 6. Which of these data sets has a greater max? And explain your answer. Well, if we're looking at the extent of the reach on the whiskers, we see that the 8th graders have the greatest maximum. The point representing the maximum is further to the right for the 8th graders than for the 7th. And looking at this box and whisker plot, which data set has a smaller range? Explain your answers. So our range from min to max, we can see and compare in either year 2000 or 2007. The data set for 2000, the distance between the points for the least and greatest value is less for 2000 than for 2007. About how much more was the median ticket sales for the top 25 movies in 2007 than in 2000? That was a year way back there. So we can look at the median ticket price here, the median ticket price here, and we can compare those two easily. About $40 million.